Modern diffusion models can synthesize stunning pixels from text, but when we try to apply them to precise business logic, the output fractures. The failures are specific and recurring. On-screen text comes out misspelled, illegible, or entirely hallucinated. Brand attributes drift from frame to frame, ignoring exact hex codes and corporate design parameters. And the entire system is non-deterministic. Running the exact same prompt twice yields two completely different visual artifacts. This creates an impossible economic reality for production workflows. Fixing a single typographical error requires regenerating and re-reviewing the entire video from scratch, with no guarantee the fix will take. The prevailing assumption in the tech industry is that scaling larger models or refining diffusion algorithms will eventually solve for exactness. The actual failure mode is an architectural error. It is a problem of misplaced authority within the generation pipeline. Generative models are designed for probabilistic sampling. They are uniquely unqualified to act as the final execution layer for deterministic business rules. Producing a usable video artifact requires making a series of discrete, verifiable decisions. This diagram outlines the artifact authority model, breaking down those requirements into 9 specific categories of decision-making. Upstream, we have syntax and semantic validity, determining if the core instructions actually make logical sense. Downstream, we have the execution authorities, design policy, brand, timing, layout, and asset resolution. When we force a neural model to hold all 9 authorities simultaneously, making it decide typography and timing as a side effect of pixel sampling, the structure collapses. The legacy enterprise alternative attempts to solve this by moving to the opposite extreme, template-based generation. Templates achieve repeatability by locking the central execution authorities into rigid, unalterable boxes. But by doing so, they forfeit all creative intelligence. A template cannot reason about a narrative, adjust pacing based on content, or adapt a layout to emphasize a critical data point. Reliable automation requires a new operating rule. Models propose, but deterministic systems authorize. To scale production without losing control, we must establish a hard architectural boundary that separates intelligence from execution. This diagram illustrates the compiler-gated sandwich architecture. It physically implements that boundary. The process begins upstream. We strictly constrain what the neural model is physically allowed to output. Relying on free text prompts or custom JSON leaves the model with too much unconstrained authority. Instead, we use a dedicated domain-specific language. This is .ws. It is a source language designed exclusively for semantic intent. The AI does not render pixels. It declares instructions like mood, precision, or intent, proof. What the grammar excludes is just as important. There is no syntax for hex codes, pixel margins, or spring physics. An AI cannot usurp graphic design authority if it lacks the vocabulary to make those decisions. Because the language relies on natural language keywords and simple indentation scoping, off-the-shelf language models can draft it with extremely high accuracy. Constraining the grammar by design filters out invalid structural proposals before a pixel is ever computed. Once the source code is accepted upstream, it passes to the downstream gate, a deterministic compiler. This node map demonstrates the policy engine at work, translating abstract tokens into concrete parameters. A single declaration maps out to dozens of specific values. This stage enforces organizational brand rules, permanently overriding model preferences. The compiler then routes the data through the internal timing solver, permanently solving the generative problem of unreadable on-screen text. This visualization shows how the solver computes reading time bounds. It relies on objective math, syllable counts, language speed, and aspect ratios, converting them into fixed frame holds. The pace adjusts dynamically. A calm educational scene computes a longer hold than an urgent promotional scene. This effectively embeds professional design and motion judgment as executable, repeatable code. Exactness and brand safety become execution properties of the compiler, rather than authoring constraints on the AI. This hierarchical data tree represents the render graph, the final output of the compiler. It is a renderer-neutral intermediate representation. Every dimension is absolute, every asset ID is hashed, and 0 creative decisions remain unresolved. Operationally, the render graph can be version-controlled, diffed, and approved by compliance teams before rendering begins. Language models, however, remain fallible. They will occasionally propose semantically invalid structures. To counter this, we rely on a bounded repair loop. Rather than having an LLM critique its own hallucination, a deterministic compiler acts as an absolute validation oracle. This diagram traces a rejected layout bouncing off the compiler date. Instead of silent degradation, the compiler generates a precise diagnostic code. The agent consumes the exact error cause, rewrites the source code, and achieves compile validity on the retry. Retry limits bound this loop, preventing infinite cycles and automatically flagging unfixable logic for human review. By using strict deterministic diagnostics, AI fallibility becomes a manageable engineering parameter instead of a fatal product defect. This architecture moves us past single video generation into macro-scale workflows, directly triggered by CRM platforms and commerce engines. Software agents need explicit, constrained interfaces to operate reliably. They cannot manipulate raw pixel canvases at scale. Human operators maintain total control by managing the policy layer, governing the fleet through structured theme packs. Updating a single brand rule instantly propagates mathematically verified compliance to thousands of autonomous agents. Secondary quality gates serve as a final check, automatically rejecting source files that compile perfectly but display weak narrative constructions. AI agents can operate as first-class video producers, provided the underlying infrastructure guarantees their output is mechanically safe. This architectural pattern extends well beyond video. It maps directly onto any high-stakes programmatic environment, from wealth management to legal drafting. It establishes the operational standard for enterprise automation, the neuro-symbolic approach. Neural models are deployed to do what they do best: reason, draft, adapt, and propose. Deterministic compilers handle the execution. They validate, govern, audit, and finalize. Achieving reliable generative scale requires shifting our reliance away from black box pixel models and building exclusively on inspectable, auditable architectures.